Hi friends, today we will see the next unit of the subject manufacturing process 3, which is surface treatments and coatings. So friends, we'll start with the definitions of surface treatments and coating. As you know, the surface treatment, the name which itself indicates, is a process which is applied on the surface of the material. Why it is to be applied on the surface of the material? To make it better in some of the way. For example, by making it more resistant to corrosion or wear. Coating. The coating is nothing but a covering which is applied on the surface of the object, and that object is usually referred as substrate. The functional coatings may be applied to change the surface properties of the substrate, such as adhesion property, wettability, corrosion resistance or wear resistance. So these two terms, that is surface treatments and coating, indicates that these are the processes applied on the surface of the material to make it better, and having coating is covering which is applied to the surface of the object, which is usually referred as substrate. Now there are many different methods by which metallic coatings may be applied, such as surface treatment, which is used to increase the mechanical, electrochemical and thermal performance of the material. The technique largely depends on the material application as well as the desired material coating or depth of the surface treatment. Now these processes are also sometimes referred as post-processing treatments, because this is the process which you have to use after completion of the production of the object. So they play a very important role in the appearance, also to the function and life of the product. Now broadly, these are the processes that affect either a thin layer on the surface of the part or add a thin layer on the top of the surface of the part. Either it is on the surface or on the top of the surface. So some of the important applications of these surface treatments and coating includes improvement in the hardness, improvement in the wear resistance, improvement in the corrosion resistance, aesthetic appearance, controlling friction, reduction of adhesion, improving the lubrication, etc. So these are some important applications for which we have to go for the surface treatment and coatings. Now we will see the different types of surface treatments and the methods. First of all, we will see what is the surface treatment type, and next the concept and applications of the process. First of all, electroplating. Now what is electroplating? As you have already learned this electroplating previous subjects. So what is the meaning of electroplating? So electroplating is the process of applying a metal coating on another piece of metal, or you can say another conductive surface, through an electrodeposition process. So in electroplating, the deposited metal becomes a part of existing product with the plating and coating. So as I told you earlier, that electroplating, which you can define as the process of applying a metal coating on another piece of the metal. How? Through an electrodeposition process. So importantly, in electroplating, the deposited metal becomes part of the existing product with the plating or coating. So this is the meaning of electroplating, and so this electroplating is employed or used in a wide variety of fields, from micro components to large products in information equipment, or also in automobiles, home appliances for ornamental plating, anti-corrosive plating and functional plating. So this is one of the type of surface treatment process. Now next we will see what is the meaning of electroless plating. So the definition is there, but what is electroless plating? It is also known as chemical plating or electrocatalytic plating in a class of industrial chemical processes that create metal coating on various materials by autocatalytic chemical reduction of metal cations in a liquid bath. So this is electroplating means in this process a method of forming metallic coating, and electrolysis plating method which does not use the electricity. In electroplating it uses the electricity, but in case of electrolysis plating the method does not use the electricity. So the reduction agent that replaces the electricity is contained in the plating solution itself. With proper reprocessing, virtually any material such as paper, fabrics, plastics and metals can be plated, and the distribution of the film thickness is more uniform but slower than electroplating. This is the difference between electroplating and electrolysis plating. In electroplating what happens? The distribution of the film thickness is more uniform in case of electroplating, but in case of electrolysis plating the distribution of film thickness is more uniform but slower than electroplating. That is, the process is same, distribution of film thickness is more uniform, but it is slower in case of electrolysis plating and it is faster in case of electroplating. So this is different from chemical plating by substitution reaction. So these are the two surface treatments, one is electroplating and another is electrolysis plating. Now what is meant by chemical coating? The process creates thin film of sulfide and oxide films by chemical reactions such as post-zinc plating chromate treatment, phosphate film coating, or it is also called as parkerizing, black oxide treatments on iron and steels, chromic acid coating on aluminum. It is used for metal coloring, corrosion protection and priming of surfaces to be painted to improve paint adhesion. So friends, we are just here discussing only the meaning of these surface treatment types or processes. In detail, in the coming lectures, we will see one by one the detailed processing of these surface treatment types. But for this lecture purpose only, in this lecture, we will just see the concepts and application of this surface treatment process. So chemical process or chemical coating is nothing but this creates thin film of sulfide and oxide films. By how? By chemical reactions, maybe post-zinc plating chromate treatment or parkerizing, black oxide treatments on iron and steels and chromic acid coating on the aluminum. The next one is anodic oxidation process. This is a surface treatment for lightweight materials such as aluminum and titanium, and oxide films are formed by electrolysis of the products made into anodes in electrolytic solution. Because the coating is porous, dyeing and coloring are applied to be used as a construction material such as sachet and vessels. There is a low temperature treated hard coating also. So just you go through this definition. In the coming lecture we will see in detail actually what is the meaning of or how this process takes place. Now we have seen about four important definitions. One is electroplating, another is electrolysis plating, then third one is chemical process, and fourth one is anodic oxidation. So this anodic oxidation is also an electrochemical method for the production of an oxide film on a metallic substrate. So in simple form we can say that this anodic oxidation is an electrochemical method for the production of oxides, for the production of oxide film on a metallic substrate. So what it does, it removes the electrons from the substance and oxidizes the anode. So anodic oxidation increases corrosion resistance and wear resistance and provides better adhesion for paint primers and glues that does bare metal. So that does bare metal. Now the next, as all you have gone through this or you know this process, that is what is the meaning of hot dipping. So the name itself indicates the meaning, what is meant by hot dipping. So hot dipping is nothing but is a form of galvanization. It is the process of coating iron and steel with zinc, which alloys with the surface of the base metal when immersing the metal in a bath of molten zinc. So hot dipping is what? Products are dipped in either dissolved tin, lead, zinc, aluminum and soldered to form the surface metallic films. It is also called as Dobzuk plating and tempera plating. Familiar example is zinc plating on steel towers. Zinc plating on steel towers. Now the next part we will see what is the meaning of vacuum plating. So vacuum coating or plating is a technique for wafer phase coating in a vacuum or in a vacuum chamber filled with an air or an inert gas. At present, the three main methods of vacuum coating have many characteristics such as no pollution, no hydrogen embrittlement, suitable for a variety of substances and relatively simple process. So in this vacuum plating, gasified or ionized metals, oxides and nitrides in the vacuum chambers are vapor deposited with this method. So methods are vacuum vapor deposition, or you can say sputtering, ion plating, ion nitriding, ion implantation. Titanium nitride is of a gold color. So all these processes such as vacuum vapor deposition, sputtering, ion plating, ion nitriding and ion implantation we are going to see in detail in the coming lectures. The next one is the thermal spraying. So metals and the ceramics, maybe oxides, carbides, nitrides, powders are jetted into flames, arcs, plasma streams to be dissolved and be sprayed onto surfaces. Typically used as a paint primer basis on large structural objects and ceramic thermal spraying for wear protection. Wear prevention. Now the next is surface hardening. So what is the meaning of surface hardening? So in metallurgy you have gone through this process, that is surface hardening. So it is also known as case hardening or surface hardening is the process of hardening the surface of the metal object while allowing the metal deeper underneath to remain soft, thus forming a thin layer of harder metal also called as the case at the surface. So this is the process of metal surface alteration such as carburizing, nitriding and induction hardening of the steel, which you have learnt in the metallurgy previous classes. The processes improve anti-wear properties and fatigue strength by altering metal surface properties. Now next is metallic cementation. So this is a method of forming surface alloy layers by covering the surface of heated metals and metal diffusion at the same time. There is a method of heating the pre-plated products as well as heating products in powdered form of metal to be coated. So friends, you might be thinking that so these are the definition and how these processes are maybe something not able to digest, but these are the processes which are very simple. Only we are seeing only here the definitions. So these are the processes which are very simple processes. Already you have gone through this. So metallic cementation is what? Cementation is a type of precipitation, which is a heterogeneous process in which ions are reduced to zero valence at a solid metallic interface. The process is often used to refine leach solutions. And the next one is painting. So there are, the painting process. There are spray painting, electrostatic painting, electrodeposition painting, powder painting methods, and are generally used for surface decorations. Also it is used for anti-rusting and anti-corrosion. Recently, functional painting such as electroconductive painting, non-adhesive painting and lubricating painting are in active uses. So these are the surface treatment types which we are going to see in detail in the coming lectures. Now we'll see what is mechanical hardening of the surface. So these methods apply mechanical impulses, that is maybe light hammering, on the surface of the metallic part. So this hammering action causes small amount of plastic flow on the surface, resulting in the work hardening of the surface layer due to the introduction of compressive residual stresses. So example of this process include shot pinning, uses tiny balls of metal or ceramics, or you can see the shot blasting also in the case of foundry, where very tiny balls of the metal that impinges on the surface of the casting and which removes the unwanted material. Or also you can have a water jet pinning, uses a jet of water at high pressures, maybe 400 megapascal, or laser pinning, surface is hit by tiny impulses from a laser, which is an expensive process used to improve fatigue strength of jet fan blades and turbine impellers. So these are the methods, that is mechanical hardening is a method which apply mechanical impulses on the surface of the metallic part. Another method is explosive hardening, where a layer of explosive coated on the surface is blasted. The resulting impact results in tremendous increase in the surface hardness. So this method is used to harden the surface of train rails. And last one we will see what is meant by case hardening. So this is very common process that is used to harden the outer surface of the parts such as gear teeth, cam, shafts, bearings, fastener, pins, tools, etc. In most of these types of components, the use involves dynamic forces, occasional impacts and constant friction. Therefore, the surface needs to be hard to prevent wear, but the bulk of the part should be tough, which it should not be brittle. This is achieved best by case hardening. There are several types of case hardening. In most cases, the chemical structure of metal is changed by diffusing atoms of alternate element, which results in alterations to the microstructure of the crystals on the surface. Actually, we have seen this case hardening process in detail in the metallurgy. Just we will revising what is the meaning of case hardening. So the basic method is simple. The metal parts are put in an oven and heated with atmosphere containing excess of gases or liquid form of the doping substance. This causes the dopant to diffuse into the surface. So the duration and the temperature control the concentration and depth of the doping. Most of these processes are used to case harden the steel and other iron alloys, including low carbon steel, alloy steel, tool steels, etc. So friends, today we will see only the introductory part of this unit 4. In the coming lectures, we will see in detail the processes which already we have discussed. So thank you very much. Take good care of your health. Thank you.